In this lesson, 6.2, we're going to take a look at angle bisectors and what that does to a triangle. And so we have the angles being bisected, cut into two congruent angles. And then we have that these segments here, DF and EF, are perpendicular. And EF would be perpendicular on this side. So that would mean that this segment here and this segment here would be congruent. The converse going the other direction is if we know that those are congruent and we know that those are perpendicular, then we know that this angle is congruent to this angle and it's being bisected. So we can go the other direction and say that the angles are congruent. So it's either going to be the segments here if we know the angles, or we have the segments and then we know the angles. So if this is 5, that would make DB 5. If this angle is 28 and we know that this segment and the segment are congruent and we have those perpendicular marks in there, then we know that this angle here, WYZ, would have to be 28 degrees as well. QS, again, we know the angles, we have perpendicular, so these segments would be congruent. So we do set these equal so we can solve for X, and then we're going to plug it back in. So X is equal to 3, and then we're going to plug it back in. So 4 times 3 minus 1 is 12 minus 1, or 11. And again, we're doing angle bisectors. And so the point of intersection is called the in-center. In-center. And this point is equidistant from the sides of the triangle. And so it's not from the vertices this time, it's from the sides of the triangle. Move my screen back down. So notice that we have our, we don't have any markings like we did on our last one with the tick marks because these are angles that are being bisected, but we do still kind of have those perpendicular. But the ones that are congruent are going to be the ones from the sides, not the vertex this time. So those ones that are perpendicular there. So for example, here it would be PT, it would be PU, and it would be PV. And I'm going to go ahead and put congruent markings actually in between them to show, even though it says which are congruent, we'll show with their symbol there. So now, PT, what is this length here is the question. Well, we have a triangle and we do have a right angle right there. So two sides, we're going to go ahead and use Pythagorean Theorem. So we're going to use our A squared plus B squared equals C squared. And remember, C is always our hypotenuse, so 13 in this case, and 12 would be one side, and our unknown is the other side. So we're going to go ahead and you can, again, take and square these, and then do your subtracting, or you can do it kind of in your calculator, and it will do the squaring and subtraction kind of all in one step, but that's totally up to you. Don't forget your square root, and A is 5. So if this segment is 5, what is PV? It's also going to be 5, just like PU would be 5, because they're all congruent there. They meet in the in-center. So the circle inside, it's in the center, and it is the same distance to each of the sides. So down here, remember that these are formed by angle bisectors. So if this angle is 28, what's that angle? 28. If this angle is 31, what's this angle? 31. So let's go ahead and find SU if S is in the in-center here. So SU, it's going to be the same length as our other perpendicular little segments to each side. So to find that, well, again, we have two sides of a right triangle. The hypotenuse is 10, one leg is 8. The other leg we don't know. So you could say SU, or you could say A or B. And then we're going to have SU squared plus 64 is equal to 100, subtracting our 64, and then we're going to have a 36 that we're going to square root to get SU, which is 6. So this is 6 right there for that length. And then SPU, that angle, is what we want to find. So SPU, this angle right here. Well, it's a triangle, and we know that up here, 28 and 28, that is going to be 56, right, for angle N. And then this one right here is going to be 62 degrees for angle M. So we can go ahead and figure out what angle P is, because we know that all three angles in a triangle, change my color, add up to 180. So minus 56 minus 62, and that leaves the angle P as being 62 degrees. But we just want this part, which is half, right? Because we're bisecting. And so we are going to take 62 and cut it in half. So SPU is actually just going to be 31 degrees. All right, let's go ahead and take a look at our missing pieces down here. Again, 21, that's 21, 28, that's 28, and UGM. Oh, we just wrote it in there, 28 degrees, because it was being bisected. MU is this part right here. Again, it's going to the in-center, which is going to be the same as UP, which is 5. So this would also have to be 5. And then BU would also be 5. And what's next? It looks like HU. HU is not 5. HU is this long segment right here. So we have one leg, we have the other leg, we're looking for the hypotenuse this time. So we do not know what C is, it's HU, but we do have the A and the B. So again, A squared plus B squared equals C squared, but we don't have C this time. That's HU, but we do have a 5 and a 12 for each of the legs. And then I'm going to go ahead and change C to HU just so we know what we're finding here. And so 25 plus 144, we don't subtract on this one, we actually add. And so that's going to give me 169, and then I'm going to do the square root still of both sides. So HU is actually equal to 13. And the last one is finding our angle PHU. PHU, this angle right here, which we already marked because we knew that it was being bisected, so it was 21 degrees.